Okay. You all can see the PDF now?
Yes,
Yes,
ma'am.
ma'am.
Okay. So this is the unit that we are going to discuss today, whose name is the Software Project Planning Unit, right? So before entering into this unit, there is a very important term which is called as the estimate. We are going to understand this term and afterwards we are going to move ahead. So by taking the general example, what we understand by estimate and where we use this term generally. For example, if we are planning a holiday, right? What we do, we always make an estimate of the budget, right? How much money is going to be spent onto our holiday, for how many days the holiday is going to be. So this is a situation where we make use of the term estimate. Similarly, if we are like conducting a marriage ceremony and we are the organizer of the marriage ceremony, then again, what will be our job? Our job will be to estimate the overall budget of the marriage that is going to include a number of the factors. Similarly, when we are planning a project development or when we are planning to develop a project, in that case also we need to make the estimate of a number of the things. Like we need to estimate the size of the software that is going to be developed. We also need to make the estimate of the efforts, the schedule, and also of the cost. So these are the four important factors that we always need to estimate about, right? So starting with this unit, first of all, in the case of the software development, what we have to estimate? Generally, we have to estimate about the estimation of the duration. That means in how much amount of the time the software is going to be completed, and estimation of the cost also. How much will be the entire amount that is going to be spent on the development of this software? So these are the two very important things that needs to be estimated, and the aim of this unit is to give an overview of the different project planning techniques, how we plan our project. Till now we have studied about what are the steps that are being involved in the development of the project, but we also need to plan about the we also need to plan about a number of the things like how much duration, how much cost, how much efforts, how many number of people, and so on will be involved in the development of this particular software product, right? So this estimation function or the management of the entire software project is done by the software project managers. You all must have heard about this designation that in the software company we have project managers. So what is the function of these project managers that we are going to see today in this lecture, right? So the responsibility of the project manager is to make as far as possible accurate estimation of the efforts and the cost that are going to be invested in the development of any software project. So basically what the project manager do, the project manager are just going to make an estimate of the efforts and cost, and his job is not just to make the estimate. Rather, he has the responsibility to make the accurate estimates. The estimate should be nearer to the accuracy. Like it is not always the case that estimates are always the exact situation. Estimate should be but near to the accuracy. They should be as much as possible, should follow the prescribed estimation of the efforts and the cost, right? So that is what we are going to go and learn in this unit, and what are all the techniques, what are all the models which are present for the software project managers in order to make the estimate of all these things, right? Before that, we are also going to learn about the various matrices that are being used in order to calculate these efforts and cost. Obviously there will be a requirement of certain measures and matrices which will be used for the calculation purpose, right? For example, we know the cost of many things that will be involved: cost of the hardwares, cost of the another softwares, cost of the building, cost of the organization, cost of the tools and techniques that will be required in the development of that particular software. So we do have the matrices for the calculation of the overall cost, for estimating the total of the cost. We are going to learn about all these techniques. So these are all the objectives of the unit that we are going to learn today. So what it says, we are going to understand the different software estimation technique. We are also going to understand the types of metrics used for the software project estimation. We are also going to learn about the models used for the estimation, and also going to learn about different automated tools used for estimation, right? There are a number of tools which are available online also, and these tools can also be purchased in order to make the accurate estimation. But generally, there are a number of models that are being used, right? So we are going to just go on to this line, which defines the estimation for us. So what we understand by that term. So the process of the software estimation can be defined as the set of the techniques and the procedures that an organization used to arrive at an estimate, right? An important aspect of the software project is to know the cost, the time, the effort, and the size. These are the 4 important factors, and etc. is also added into this, which needs to be estimated and in the development of any software project. So we have understood the estimation. Estimation is just a rough idea which should be nearer to the accurate idea, right? It is not always expected that that rough idea will be like exact cost. Means if I'll just say I estimated that 10 lakhs rupees will be estimated in the development of any particular software. It is just an estimate. It could be more than 10 lakh also, and it could be less than 10 lakh also. But this 10 lakh should be such an amount that it is nearer to the actual amount. So that what comes in the estimation part, right? And what are all the factors that are being involved in this estimation part? These are all the factors, like you need to make the estimate of the cost, you need to make the estimate of the time, you need to make the estimate of the efforts, and also the size, right? Then what is the need for the project matrices? We do have the various matrices which are being used for making this estimate or for the measurement of the software process. Matrices are what? Matrices are all tools which are used for the measurement of the software processes and the software product also, right? It has always been, there is a very famous saying which says that if you cannot measure it, then you cannot improve it, right? So measurement is very, very necessary. If you have measured, then even if you have measured it wrongly, then also there is a scope for the improvement in that case, right? So the software development projects are the quite complex project, and there was no scientific method of measuring those software processes. Then the software matrices comes into play, and their function is to measure the software process and the software product also, right? So matrices are often used to estimate the cost of the project and the schedule of the project. Schedule of the project means the duration of the project. How much amount of the time will be required for the development of that project is also needs to be estimated. These 4 factors which are written over here, cost, time, efforts, and size, so they come into this only. First is your estimation of your cost, and second is the estimation of the schedule, estimation of the duration. You all must understand the term schedule means the timetable or which needs to be followed, or the total amount of the time from the beginning of your project to the end of your project, that comes under the schedule. That includes till what duration which part of the software development is going to be performed. That is basically the schedule part of your software. Now, there are various examples of the matrices which exist for us. One is your LOC, which is your line of codes. Means how many lines are present into the coding of any particular software, that is being calculated and that is being computed in the lines of the code. Then the second example of the matrix is the pages of documentation. Whenever you have done the documentation, how many number of pages are there? Then the number of men and month means how many number of people are working for how many number of months in order to complete this project comes under the man month. Man month means a person working for how much amount of the time. That time could be into the number of months also. That time could be into the number of the For example, number of the days also. So that a particular person working for 2 months, 3 months is that comes under your man month matrix. Then number of test cases. Whenever the testing is being performed, then we develop the test cases for performing the testing. So number of the test cases is another kind of the matrices to calculate or to sum up the total number of the test cases. Then number of the input forms. Input forms are also being generated. So that also comes under your matrix part. Now, types of project matrix. There are basically two types of the project matrix. Project matrix means we are talking about the software project matrix. First is our product matrix and second is our process matrix. Just understand it like this. The software project matrix means software project measurement tool are divided into two parts. The first is our product matrix and the second one is our process matrix. So what comes under the product matrix? It provides a measure of the software product during the process of the development, which can be in terms of lines of codes or the pages of documentation. So product matrix is going to measure the software product when it is into the development stage, right? And process matrix is a metric or it is a measure of the software development process, such as the time and the efforts, how much effort is being given into the development and how much time is being required. So example of the product matrix is your number of the pages of documentation, line of the codes, and the example of the process matrix is your time and the efforts. Now we have also classified our metrics into two more types. One is a primitive matrix and another one is our derived matrix. Generally, the two matrices that we make use of are the product matrix and the process matrix. Then another way of classifying the matrices is on the basis of another way of classification is primitive matrix and the derived matrix. Primitive matrix are the directly observable quantities like the line of codes again and the number of men and hours. Those quantities which can be directly observed, which can be directly calculated, comes under the primitive matrix. Derived means that they are depending on some another factor. For example, the line of code per man hour is the example of derived matrix. Error per 1,000 line of codes means if we are calculating the error or if we are just focusing on to the error, then what errors are depending on what? Errors are depending on to the 1,000 line of code. Means in the case of the derived matrix, there is a dependency onto the another matrix. For calculating the errors, the dependency is onto the 1,000 line of codes. Means in this kind of the matrix, the errors in the first 1,000 lines of the code will be found out and they will be calculated. Then errors in the next 1,000 lines of code will be calculated. So that comes under the primitive. Primitive means the direct form of the matrices or the quantities which are directly observable. Derived means quantities which are dependent onto the primitive matrices only. So in this case, the matrices have been discussed. Matrices are basically the tools for the measurement of the software product. Then we have divided the matrices into two parts, product matrix and the process matrix. And there is another way of classifying the matrices, which is our primitive matrices and the derived matrices. It is clear?
Yes.
Okay. Then moving on, we are going to understand more about the product matrix and the process matrix, right? This is just another way of classification which could be considered, but majorly in the software companies, these two type of the matrices that are majorly being used. So we are going to read about the product matrix first of all. In the product matrix, what we have the lines of code. So lines of code matrix is possibly the most extensively used for the measurement of the size of the program. What the lines of code are saying, lines of code are just going to depict us how many lines are present into the entire code of the software program, with software that is being developed, right? So when we calculate the entire number of lines which are present in our software, then what it is going to give us, it is just going to tell us about the size of the program, right? If anybody just ask us what will be the size of the program, obviously then we are going to measure the lines of the codes which are present into the program, right? Now, lines of the code may include the executable source code also and the non-executable program code like the comments and comment thing present into our programs, right? So line of codes include everything, every line which is present into the into the development of the software. Every line which is present into the coding part of the software is going to be calculated by the line of the codes. Now we are going to just look at this table which is present in front of us, and we are just going to read it. It has got the three columns. The column 1 is just representing to us the modules. Column 2 is representing us efforts in man months. And column 3 is just telling us about the LOC, which is our line of codes. So first row is saying module 1, efforts in man month is 3, and the line of codes are 24,000. Module 2 is saying us there are, for the development of the module 2 of the software, the 4 man months are required and 25,000 lines of codes have been written, right? So in order to calculate the productivity of any person, how we are going to calculate it? We are going to divide these line of codes by man month. So if we divide line of code 24,000 by 3, what we are going to get? We are going to get 8 as answer, right? And if we are going to divide 25,000 by 4, we are going to get something 6 point something as our answer. So it is evident that productivity of the developer engaged in the module 1 is more as compared to the productivity of the developer engaged in the module 2. So this is how we calculate the productivity of the persons which are engaged in the development of the module 1 and module 2. And by calculating this, by making use of this formula, line of code divided by man month, we will be able to calculate exactly how much amount of the productivity is being given by the module 1 people and the module 2 people, and then we can make a comparison, obviously. Then quality of this work can also be computed. How the quality is going to be computed? Quality is going to be computed by calculating the number of defects dividing by the line of codes which are being considered for the calculation of the defects, right? So it is important to note here that how derived matrices are very handy to project managers to measure the various aspects of the project. Now, the LOC or the line of the codes provide a direct measure of the program size. At the same time, these matrices are not universally accepted by the project manager. So looking at the table which is present above, it can be easily observed that line of code is not an absolute measure of the program size and largely depends on to the computer languages and the tools used for the development activity. This line we are going to understand by following table, right? Line of codes are not considered as the absolute measure of the size of the program because it is also dependent on to the another factors such as, for example, we make use of any of the language for developing our software project, right? For example, a company A is making use of the COBOL language and the company B is making use of the assembly language for the development of the software, right? So when we see the following table, what we see for the module 1, the effort in man months is 3. Line of codes present while making use of the COBOL language for its development is 24,000, whereas 8 lakh lines of codes are being written for the development of the codes in the assembly language. And when that particular coding is done into the 4GL language, then only 400 lines of codes are written. Similarly, for the development of the module 2, the efforts in man months are 4, line of codes in COBOL are 25,000, line of codes in the assembly language is 1 lakh, and line of codes into the 4G language is just 500. So just see the difference. We are developing the same software, but we are making use of the different languages. And when we are making use of the different languages, the line of codes are changing in each and every language. So when the line of codes are changing, that is why it is not being taken as the absolute measure of the program size. What it says that the line of codes of the same module varies with the programming language used. Hence, just line of codes cannot be considered as an indicator of the size of the program. It just depends on to the language also, which language is being used for the development of that particular program, right? So there are another attributes of the software which are not directly reflected into the line of codes, as the complexity of the program is not being taken into consideration. There are another disadvantage of the line of codes, which is what the project manager is supposed to estimate the line of codes before the analysis and the design is being completed. So the manager has to make the estimation for these line of codes. So it is again not necessary that the estimation is going to be the exact line of codes only, right? So that has also become a very difficult task for the project manager. So in these two lines we have learned about the disadvantages of the line of codes. That is why we are going to move on to the another type of the matrix, which is going to be our function point matrix, right? So till here we have seen how the line of codes are affecting the productivity of the person, or they are just helping us to calculate the productivity of the persons, and then the quality can also be calculated with that. But sooner with the time it has been observed that line of codes cannot be considered the only factor which is being utilized for the development, which is being utilized for the measurement of the estimation of any software project. So moving on to, because it has been seen that when the languages used for the development of the software project are changed, then in that case, the line of codes are also varying. It has not been seen, it has not been like that key line of codes are remaining the same, whatever language is being used for the development of the project. So after seeing all these disadvantages of the line of the codes, we have moved on to the another kind of the matrix, which is called as a function point. So function point matrix, instead of the line of codes, measures the functionality of the program. As the name indicates, what the function point is going to measure, the function point matrix is going to focus onto the functionality of the program. This matrix is being developed by the Alan J. Albers in the year 1970s. So these are the four factors, not four, five factors that are being considered whenever the functional point analysis is being done. So what these five factors are: external input, external output, external user inquiries, internal logical files, and the external interface files. So all these 5 points needs to be considered whenever the function point matrix is being discussed, or whenever the function point matrix is being used for measuring the software project, right? So what the external input says, the external input says that it is a process by which the data crosses the boundary of the system, right? Data may be used to update one or more logical files. It may be noted that data here means either business or the control information only. External input means what are all the inputs coming from the like inputs given to any of the software, or inputs given to the software that is being developed comes under the external inputs. In the case of the external output, what are all the outputs that are being generated by the software, or what are all the outputs which are crossing the boundary of the system, or all the outputs that are going outside the boundary of the system comes under the external output, right? Then for example, it can be a user report or a system log report, right? Then the external user inquiries. These are the count of the processes in which both the input and the output results in the data retrieval from the system. Inquiries means some inquiry has been made, and obviously there will be an answer to that inquiry will be. So it includes both the input and the output results in data retrieval from the system, right? Then the internal logical files. There will be certain set of the files which will be present inside the development of the system, or there will be certain logical files which will reside inside the boundary of the application software, and they're also being maintained. These files are being considered under the internal logical files. Then the external interface files. Obviously there will be a logically related files, or the group of the logically related files that will be used by the system for the reference purpose only, right? So for that, the system is going to go and check to another files, or going out of its boundaries. All those things will be coming under the external interface files. So what we have till now in the case of the function point analysis, the following features are considered. The first feature is my external input. Any of the input that is coming outside of the software system comes under the external input. External output is any of the process that is crossing the boundary of the system is the external output. External user inquiries, any of the processes that includes both input and the output comes under the external user inquiries. Internal logical files are basically the files that are residing inside the system only. These are the internal logical files. Then we have the external interface files. Obviously, there will be certain files which needs to be referred and which are residing outside the boundaries of the system. These are the files which comes into the category of the external interface file. Now, as we see, the function points, unlike the LOC, measure a system from a functional point of view or the functional perspective, independent of any technology, any computer language, or any development method, right? Whereas the LOC is dependent, or the line of codes metrics was dependent onto the technology also, the computer language also, and the development method also. Whereas the dependency of the functional point is onto the functional part of the software system. So this is how it is going to work. We are going to see all these tables also. So for the transactions like external input, external output, and user inquiry, the ranking of the high, low, and medium will be based on the number of the files updated for the external input or number of files referred for external input and external inquiry. What we can see in this table, we have seen that there is a term high, low, and medium that is being used. High, low, and medium are representing how many number of the files that are being exchanged or how many number of the operations that are being performed in the case of the external input, external output, or the user inquiry. So we are going to just see this table. So what we have in this table, in the column, we have the number of the data elements. In the next column, we have the number of the file references, 0 to 2, 3 to 4, and 5 and above. These are the values that are being used for the number of the file references. So for the data element from 1 to 5, the number of file references are low in the case of 0 to 2. Then in the case of 3 to 4, the file references are again low. And in the case of the file references 5 and above, it is again low. Then talking about the data element 6 to 10, the 0 to 2 file references falls into the category of the low, then medium, and so on, right? Now, also the external inquiry, external input, and the external output based on complexity can be assigned the numerical values like the ratings. For example, we have got the component external output, external input, and external inquiry. Values can be given to them on the basis of the rating. So the functional point thing majorly works onto the numerical values. Like we divide the ranges. From this range to this range falls into the category of the low. From this range to this range falls into the category of the medium. Then from this range to this range falls into the category of the category high. So it depends on to the organization that the ranges are basically depends on to the organization that they are taking the values ranging from where to where, right? So that comes under this. Then external logical files values are being shown like this: low, medium, and high. 6, 8, 10 external interface are like this. So organizations may develop their own strategy written over here. You just need to pay the attention that the organizations have got this authority that they can have their own strategy to assign these values. You will be wondering from where these values are coming. These values are just dependent onto the organizations only. They have got this authority to develop their own strategy in order to assign these values to the various function points. So once the number of the function points have been identified and their significance has been arrived at, the total function point can be calculated like this. So first of all, in the table, we are going to write the types of the component: number of the external output component, number of external input component, number of external inquiry component, number of logical file component, and number of the interface file components, right? Then we are going to write about, just see this section, low, medium, and high. For the external output, it has been written over here X4, X6, and X8. From where this 4, 6, and 8 has come? This has come from here only, 4, 6, and 8, right? The component name is external output. Component name is external output. The values of low, medium, and high is 4, 6, and 8, right? The component name is external input. Component name is external input, and the values are 2, 4, 6, then 3, 5, 7, then 6, 8, and 10, and then the 5, 7, and 9, and then the total of all these components are being performed, and this total is to be considered as the function point. So it has been written over here. Total of the function points is calculated based on to the above table, and once the total of the function point is calculated, another derived matrix can be calculated. How the another derived matrix can be calculated? It can be calculated like this. The productivity of the person is calculated by dividing the total of the function point by the man month. Similarly, the quality can be calculated by dividing the number of defects by the total of the function point. You just need to see the difference from here to here. In the case of the LOC, when we were calculating the productivity, what we were doing, we were dividing the line of codes by man month. Quality, when we were calculating, we were dividing the number of defects by LOC. Whereas in the case of the function point, what we are doing, in the calculation of the productivity of the person, we are dividing the total of the function point by man month. And in the case of the calculation of the quality, we are dividing the number of defects by total of the function points. So this is what is happening in the case of the function point. And all these numbers are just like, it totally depend on to the organization, their strategy to assign these numbers and to decide the range also, that from where to where the numbers are being assigned in the low range, in the medium range, and in the high range. Then the total is being performed for each and every output or for each and every component, and then that total is going to be called as our function point. And after that, we just calculate the productivity of the person and the quality of our software by performing this computation. Now we are going to see that what are all the benefits of using the function point, right? So first benefit of making use of the function point is, just a second. Okay, so the first benefit is function point can be used to estimate the size of the software application. Obviously, we can calculate the size of the software application correctly, irrespective of the technology, language, and development. Yes, we have known. That is why the function point has come into the picture, because we know in the case of the line of codes, there was a dependency onto the another factor also. But in the case of the function point, there is no dependency onto which technology is being used, which language is being used, and which development methodology is being used for the development of any of the projects. Second, the user understands the basis on which the size of the software is calculated, as these are derived directly from the user required functionalities. Third is function point can be used to track and monitor the projects, in which stage the project is working and how the project work is going on is also being calculated with the help of the function point, or there can be a track record that can be maintained in that case. Then last advantage of the function point is it can be calculated at the various stages of the software development process, and then it can be compared also, right? We can calculate a function point in any of the stage of the software development, right? If the software is in the stage of the designing phase, or the development of the software is right now, if it is into the testing phase or the coding phase, then in the various stages, the function point can be calculated, and then it can also be compared also, right? After that, there are another two types of matrices which are also available to us for the measurement of the quality of the software, or for the measurement of the estimation of the software. The first is our defect matrix, and second is our reliability matrix. In the case of the defect matrix, what it is going to measure, it is going to measure the number of the defects which are occurring into the software product, right? As the name indicates, what will be the function of this defect matrix? The function of this defect matrix will be to measure the number of the defects that are existing into the software product. This may include the number of the design changes required, number of the errors detected into the testing phase, right? So defect matrix is going to be basically concerned onto the concerned or focused onto the defects which are existing into your software product. Then in the case of the reliability matrix, these matrices measure mean time to failure, means how much amount of the time is being required, or how much amount of the time is being taken in the failure of any software product. So that is being considered into the reliability matrix, and this can be done by collecting the data over a period of time. You just kept on collecting the data, and then just you are going to calculate the amount of the time in which the product is going to be failed. So reliability matrix means to basically calculate how much reliable is our software, how much less amount of the time it is taking to how much more amount of the time it is taking to fail. That is being considered in the case of the reliability metrics, and the defect metrics mainly focuses on to the defect part of any of the software product. Understood?
Yes.
You all are listening now?
Yes, ma'am.
Okay. It's a very theory part of the subject. So just
Yes, ma'am. Yes, yes.
है ना, keep on reading also whatever is being written, and keep on listening also whatever I'm explaining. Fine.
Okay, ma'am.
Okay. So this completes our matrix part. How many types of matrices are there? So how many types of matrices are there?
4.
Let us just revise it first. Okay. So what is the name of the first two types of matrices?
LOC function point.
No, that comes under what?
Product
Size of product.
product
No.
metrics and process metrics.
Yes. The first two type of the matrices are the product matrices and the process matrix. Inside the product matrix, what we have read? We have read about the LOC, line of codes, and the function points. Then on the basis of the another way of classification, again we have divided the matrices into two parts. What are the name of those two parts?
Parametric metrics, one more is, I think, observable.
Yes.
Yeah, first one.
No one else is listening to me, right? Only the Shahapur
Derived.
is listening. Yes,
Yeah.
derived metrics.
Yeah,
Right,
metrics.
absolutely right. The another way of the classification is your primitive matrix and the derived matrix, right? Then after that, we have studied about everything, how we calculate the productivity and the quality of the software by making use of the line of codes, and also by making use of the function point. And then at last, we have discussed about two more metrics. The first is, the name of the another matrix is?
Defect
There are two
matrix.
defect metrics, absolutely right. And the last one is our
Reliability.
reliability metrics. Fine. So I should consider that you all are understanding whatever I'm telling to you. You are able to read that also and grab that also. Fine.
Yes, ma'am. Fine.
Okay. So now we are going to go on to our next topic, which is going to be what software project estimation, right? Till now, we were just studying about the matrices, which are again used for measuring the productivity or the quality of the software. Now we are going to go to our next part, which is going to be the software project estimation. So what this software project estimation is doing, it is basically the process of estimating the various resources required for the completion of a project. I have also explained you earlier also, for example, if we are going to plan a holiday trip, we have to make an estimate of everything, right? We have to make an estimate of the number of days, number of people, number of amount of the money, and so on. So what all those things are basically the estimate only, right? Similarly, when we wanted to develop a software project, we need to have an estimation of all the resources that are being required for the development of our project, or that are being required for the completion of our project, right? Effective software project estimation is always a very, very important activity. Why? We are going to understand it, because if we underestimate the software project and do the understaffing, it is going to result into the low quality of the deliverables, and the project misses its target deadline also. And if we overestimate, then what happens? Then we are going to compromise onto the cost of the project and reduce the competitiveness of the company. So underestimation is also harmful, and the overestimation is also harmful. What is happening in the case of the underestimation of the software project? There are going to be the problem of the quality of the software that is going to be delivered, and also the customer dissatisfaction and the loss of the credibility is also going to happen to the company, right? The company is going to suffer with both these two is going to suffer with these two factors also. The one is the customer. Obviously, if the low quality product is going to be delivered to the customer, he's not going to be satisfied with the work of the company. Second thing, if the project date is going to be missed, means the date on which the project was going to be delivered was also being missed by the company. So again, the loss of credibility is going to happen to the company. So this happens if the underestimate of the overall resources requirement is being performed, right? And if overestimate is being done, means the number of the more number of the staff is being hired for the development of the project, then what is going to be happen, the cost of the project is going to increase a lot, and that is also again going to be a disadvantage for the company only. So both overestimation and the underestimation are not going to be good for the software project also, because the low quality project is going to be developed, and it is also never favorable for the company point of view also, right? So the major steps that are being included in the software project estimation are: first is estimating the size of the project, second is estimating the efforts, third is estimating the schedule, and fourth is estimating the total cost of the project. So we always should remember these four important points: size, efforts, schedule, and the cost. SESC, that is how we remember them. SESC means S for first S, it is going to be size. For the E, it is going to be efforts. For the S, it is going to be the schedule. And for the C, it is going to be the cost. So the abbreviation what we make use of, we always make use of SESC in the case of the estimation of the software project. So first is our estimating the size of the project. What is going to be included in that? There are many procedures available for estimating the size of the project. For example, estimating the line of the codes and estimating the function points, right? Size of the project means we are just going to calculate the number of the lines which are going to be present into the code which has been written for the development of the software, right? So that is going to tell us about the size of the project. Then estimating the efforts based on the man month or the man hour. Man month is an estimate of the personal resources required for the project, means how many people are required for the entire duration of the month, or how many number of the people are working for the month, and what is the output they are being giving after working for the whole month is going to be estimated. In the case of the efforts, means how much effort are being required for the development of the project. Third point is estimating the schedule in calendar days or months or years, means you have to sit and you have to just make an estimate about the amount of the time that will be required for the development of this software project. It could be in the number of the days, it could be in the number of the months, and it could be into the number of the year also, right? And it is also based on to the total man month required and the manpower allocated to the project. So duration in the calendar month, we calculate like this: total man months divided by the total man power. Next is estimating the total cost of the project depending on to the above and the another resources. By calculating all the above resources, we get all the above factors, and by calculating all the above resources, we are going to make an estimate about the total cost that is going to be included for the development of this project, right? So now we are going to consider this table. What this table is saying to us, it is just telling us about the activity, and it is also telling us about the task involved. So in the case of the planning activity, these are all the list of the tasks that are involved. What are all the tasks? Planning means software planning, right? So task involves are cost estimation, planning for training of the manpower, project scheduling, and the budgeting of the project, right? In the activity controlling, these are all the things that are being involved. Size matrix and the schedule matrix helps the manager to keep control of the project during the execution. Monitoring and improving matrices are used to monitor the progress of the project, and whenever possible, sufficient resources are allocated to improve. So what is happening in the case of monitoring? Obviously, they help us to monitor the progress, how much progress has been made into the development of the project. If it is not up to the mark, if it is not up to the schedule, then obviously the project manager is going to do a hurry in order to complete the project onto the time. So we are just going to read it from here. In a commercial and a competitive environment, software project estimation is crucial for the managerial decision making. The following table gives us the relationship between the various management functions and the software metrics indication. Now we have another figure which is going to just explain us the software project estimation. So in between we have the software project estimation. What all we need for making the estimation? We are in need of the user requirements, what are all the constraints, what are all the things that cannot be done, and what are all the policies of the organization, what are all the standards, what are all the benchmarks which are existing into the organization which is developing the software. So by including all these factors, by including the requirement of the user, by including the constraints, by including the organization policies and standards, what will be the output? The output will be an estimation of the project schedule, how much amount of the effort is being required, and how much cost will be required for the development of the project. So this figure is the overall depiction of the process of software project estimation. It is just showing us the software project estimation process requires all these things as the input. What are all these things? The user requirement is there, the constraints are there, and there is also a consideration onto the organizational policies and standard. And then by looking at the output side, we are just going to see the output will be in the form of the schedule, effort, and the cost. So this is how we explain this diagram. So first of all, we are going to just read about estimating the size of the project. So estimating the size of the project means estimating the size of the software to be developed is the very first step to make an effective estimation of the project. So customers' requirement and the system specification from a baseline for estimating the size of the software. So the ways to estimate the project size can be through how we estimate, means how a company going to estimate the size of the project. Obviously, always the past data is being referred in order to estimate the size of the project. Means the company is going to go to its archive section and it is going to check whether this kind of the project has been developed by the company earlier or not. If the similar kind of the project is being developed by the company in the past also, then the company is going to take that past project as the reference and then going to make the estimate of the size of the project, right? So whatever the work has been done by the organization in its past is going to help the organization in order to estimate its size. Then another way of estimation is through the product feature or the functionality. Means by dividing the entire system into several subsystems and subsystems depending on the functionality and the size of the each subsystem is calculated. Another way of calculating or estimating the size is to just bifurcate the system into the subsystems and then calculating the everything about those subsystems, calculating the functionality of the subsystem, calculating the size of the subsystem, and then adding all the points together, adding all the outputs of the subsystem or adding all the size of the subsystem together and getting the overall size of the system, right? So there are basically two different methods which can be utilized in order to estimating the size of the software. The first method says that refer to your past project, and the second method says that just divide the system into subsystem and calculate the size of the subsystems and then just add them all together and calculate the overall size of your entire system. So this is happening into the second case, right? This is how the organizations estimate the size. Now estimating the effort. In the case of estimating the effort, what is happening? Because we know that the development of any application software is more than just coding part. We have studied about the SDLC. We know what all is going into the development of any of the software product. So efforts are estimated in number of man months. When we are talking about the efforts, how they are being going to be calculated, they are being going to be calculated with the help of this matrix, which is called as the man month, right? So the best way to estimate the effort is based on the, obviously, again, in the case of the efforts also, or in the case of estimating the efforts also, the organization is going to refer to its historical data in order to just in order to just establish an analogy between the present project and between the past project. If there is an analogy, if there is a dependency, if there is a certain kind of the relationship, then then that particular relationship can be used for estimating the effort. And the second is, if the project is of the different nature, which requires the organization to adopt a different strategy for the development, then the different models based on algorithmic approach can be devised to estimate the effort. If it happens that there is no similar kind of the project that has been done by the company into the past, then the company has to develop a model by making use of the wages algorithm in order to devise the or in order to estimate the efforts. Now the company has to work from the different perspective, because now the company do not have the model of such kind in the past. So now what it has to do, obviously it has to be dependent onto the development of the another model by making use of the various algorithm, and then just estimate the efforts, right? Third is our estimating the scheduling part. So in the case of estimating the project scheduling part, what is being done, the schedule in calendar month is calculated like this: the parameter 3.0 multiplied by man months and raised to the power 1 by 3. It has been written over here. Efforts in man months are translated to the calendar months. So how many months are being there into the calendar month? They are being used like this. Schedule estimation in calendar month can be calculated by making use of the following model, which is called as a MCAOL model. You just need to know about this, need to know about the name of this model and the formula of this model, right? Now this parameter 3.0, which has been written over here, it is a variable, and it just depends on to the organization to organization, that it can be changed also. In spite of 3.0, it can be taken as 4.0, and it just depend on to the particular project that is being developed by the company, and on the requirements of that project, that which variable is going to be more beneficial in this case whenever the McConnell model is being used, or whenever the estimation of the schedule is being done by making use of this particular equation. Now, in the case of estimating the cost, which is going to be our fourth factor, what is being done? The cost estimation process is this. Just see this diagram. What is coming into it? The efforts are coming. The hardware cost is coming. The travel expenses are coming. The training cost is coming, and the communication cost and the another cost factors. Everything is being taken into consideration. All these are the inputs for the cost estimation process. And then by calculating the overall cost, we are going to just say that we have estimated the total cost of the project, right? So this is the cost estimation process, in which the cost of the project is derived not only from the estimate of efforts and size, but also dependent onto the various another factors, which are these: hardware cost, travel expenses, training cost, communication cost, and the another cost factors, right? The cost of each and every point is being fed into the cost estimation process as an input, and then the total or the overall cost of all these factors are considered as the estimated project cost. Now, figure 5.3 depicts us the project estimation process. So this is the entire process of the project estimation. First of all, what the project manager has, the project manager has got the user requirement. His function will be to estimate the size, estimate the effort, and estimate the cost. Now, estimate efforts are also going to play as a role in the case of estimating the schedule. And this schedule estimation is also going to make use of the resources which are being used for the development of the project. And for estimating the size and the efforts, obviously, one parameter that is going to be taken into consideration was the data from the past projects. If there is a similarity between the data from the past projects, obviously they will be taken as the reference point from the point of view of estimating the size and estimating the effort. So this is the entire process of the project estimation. Have you all understood these two diagrams?
Yes, ma'am.
Okay. Then we are going to move on to the another thing, which is going to tell us about the dependency of the accuracy of the project estimation. So obviously, when we are just kept on repeating the term estimate, 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 right? So it is a possibility that this estimate can differ from the actual situation. So, but the overall efforts of the project manager is what? That this estimation has got a accuracy, right? Whatever the estimation we are making of, whether we are making of the estimation of the size, effort, cost, or the schedule, then those estimates should lie nearer to the actual cost, which is going to be occurring into the future only, because estimation is made before actual cost is coming, right? So these are all the factors on which the accuracy of the project estimation depends on. The first is the accuracy of the historical data that is used to project the estimation. Obviously, as we have seen that there is a lot of dependency onto the historical data. So on this historical data also the accuracy of the estimation depends. Then the accuracy of the input data to the various estimates. As we have seen, there is always an input data. There is always an input data. And how much accurate the cost of these input data is being depicted is also a point in the case of calculating the accuracy of the estimation. Then the maturity of the organization software development process means the experience of the organization also comes into play whenever the estimation is being made. The more the experience the organization is having, the more it will be able to predict the correct cost of the project, right? So that is happening into the case of the project estimation. Now we are going to see there are a number of reasons which are going to make this task quite difficult. Task of what? Task of the cost estimation. Why? Because the software cost estimation requires a significant amount of effort. Sufficient time is not allocated for the planning. Now, the software cost estimation is often done hurriedly without an appreciation for the actual effort required and is far from real issues. Lack of the experience is another factor, and an estimator uses the extrapolation technique to estimate, ignoring the nonlinear aspect of the software development process. So these are all the 4 points which are just telling us what are all the factors or what are all the reasons that make the task of the cost estimation as a difficult task. So these are all the points, whether it is going to be not proper amount of the efforts are being paid whenever we are trying to estimate the cost, not, and the process of estimating the cost is made into hurry when the various extrapolation techniques are not taken into the consideration, but the non-linear part is not taken into consideration, and the lack of the experience of the developing team is also can be the another major factor that can result to a bad estimation for the cost. Now there are various reasons for the poor and the inaccurate overall estimation. These are the factors for the cost estimation only. Now these are the factors for the overall poor and the inaccurate estimation. What are all these factors? When the requirements which are given by the client are not precise in nature, the requirements changes frequently, the requirements are not the apt requirements, right? In that case also the estimation is going to be suffer. In the second point, the project is new and is different from the past project. Now when the organization do not have anything to refer to, there is no historical data which is available to the company in order to just take an idea, then in that case also means the project is very new, then in that case also the estimation is going to be affected. Now the non-availability of the enough information about the past project, obviously we have discussed it onto the above point also, and the estimates are forced to be based onto the available resources. Estimation has to be done on the basis of all the resources which are currently available to the company, right? It do not consider the resources which might come into the future or which might be required by the software project development into the future. So only the current resources are being taken into the consideration by the software project company, and that acts as the disadvantage or in the case of the estimation. Now cost and the time trade-off, we are going to discuss it. What it says is it says that these are all the points which are describing us the problem which are coming into the process of the estimation. So what are all the problems that our companies facing? Estimating the size is often skipped and as a schedule is estimated, which is of more relevance to the management. So that is also going to be what the organizations are basically escaping, how the organizations are basically escaping, that they just skip the estimating the size of the project. What they just do, they just try to estimate the schedule only, right? Next thing is estimating size is perhaps the most difficult step which has a bearing on all another estimate. Yes, we can even think by ourselves that whenever we need to estimate the size of the project to be near to the accuracy, it is going to be a very difficult task, because to estimate the number of the lines of the codes that are going to be into the software project, and if the project is very new in nature, then it is going to be a very, very difficult task. It is just going to be a completely difficult task for anybody to estimate the number of the lines which are going to be present into any of the software. Next thing is, let us not forget that even the good estimates are only projections and subject to the various risks. Yes, we know that. We are just saying that estimate, estimate, estimate. The good estimates are just only the probability of happening. They are not just the surety that only this is going to be the correct situation or the real situation. So they are always subjected to the various kind of the risk. Now, the organizations often give less importance to collection and analysis of the historical data of the past development projects. That is why the organizations always suffer with the estimation of the new project that has come to the picture now, right? Because the organization pay less amount of the efforts, organization pay less amount of its time in order to collect and analyze the historical data. They have just saved it, and they just ignore the historical data in the case of the estimation of the new project. So that is again going to be kind of the disadvantage for the organizations. Now, the project managers often underestimate the schedule also, because management and the customer often hesitate to accept a prudent, realistic schedule, right? Why? Because if the client is there or the customer is there, the customer is going to give a time frame, or the customer is going to give a time schedule that onto that particular date or onto that particular month, I just want my project to be delivered. But actually only the project team and the project managers know how much amount of the time is going to be taken by that particular project and the product, right? So it is always like kind of the problem in estimating the schedule, and it is always a kind of the problem in informing to the customer about the schedule of the actual schedule of the project. So these are all the problems that arises in the case of the estimate. Now, there are certain kind of the guidelines that is also present to the software development organization in order to have a better project estimation. So what are all the guidelines? The guidelines are as follows. First is preserve and document the data pertaining to organization's past projects. So the most important thing, as we are studying also, is what is to preserve the data that has been done in the past history, or the historical data is always important for the organization to collect it, to preserve it, and to analyze it, because it is going to be very useful into the present project for the organization. Next is to allow the sufficient time for the project estimation, especially for the bigger project estimation. For the task of estimation also, it shouldn't be done into a hurry. The organization should allow the sufficient amount of the time, and it should allow the project manager to give the sufficient amount of the time so that the good estimates can be done. Then prepare the realistic developer-based estimates. Associate people who will work on the project to reach at a realistic and more accurate estimate. Obviously, the estimates should be the realistic kind of. It should not be haphazard estimates. They should be available, and they should be considered only for the estimation purpose. The next kind of the project estimation guidelines is use of the software estimation tools. Yes, there are various tools that have been developed whose function is to do the estimation work for the development team. So these tools can also be used for the software estimation purpose. Now, re-estimate the project during the life cycle of the development process. Now, if during the development process or during the life cycle of the development process, it has been seen that our development process is lagging far behind as our estimated process, then it should also re-estimation of the project should be done in that case. Whenever there is a lot of difference between the reality and the estimation thing, then and in that case the re-estimation should be done. So these are all the guidelines which, if followed, is going to help the software organization to have a good estimate of all the important factors, whether it is going to be good estimate of the effort, size, duration, time, cost, and so on. So these are all the important guidelines. Next is analyze the past mistakes which have been done in the estimation of the project. This point was missed, so we are going to take this point also. If any of the past mistake is being performed by the organization, then that past mistake should not be repeated in the present estimation of the project. So that is the last point into the estimation thing. Now, we have studied about the various estimation, how the software project estimation is done, how we estimate the size, how we estimate the efforts, how we estimate the cost, how we estimate the schedule. Now, we are going to see the number of the models which are existing for the estimation purpose. We just don't need to worry about the various equations that are being used into the models. For example, these equations are there. We just need to know what are all these models and how they are functioning, right? The first model is our estimation model. They are based on to the first model is my COCOMO model, COCOMO. You call it as a COCOMO model, right? So the estimation models are mainly dependent on to a particular kind of the relationship or dependent on to this equation, which is read to us like this: E is equals to F of VI. Now, what is this E? E is the different project estimates like effort, cost, schedule, etc. E is the estimate of all these things. VI is the directly observable parameters like the line of codes and the function points. So the estimate are going to be a function of this. So we need to know about this equation or this relationship which is existing among the estimates, project estimates, which is a function of the various parameters or the various observable parameters like the LOC and the function points. Now, what is happening into the COCOMO models and how many levels are there into the COCOMO model? There are mainly 3 levels into the COCOMO model. First is our basic COCOMO, then we have the intermediate COCOMO, and then we have the detailed COCOMO. So COCOMO stands for what? COCOMO stands for the constructive cost model. It is the full form of the COCOMO. What it says? It says constructive cost model. And it was given by whom? It was given by the Barry Boehm. We also sometimes refer the COCOMO model as the Boehm model because it was given by the Boehm only. Right. And it is perhaps considered as the best known and the most thoroughly documented of all the software cost estimation models. One of the best model among the estimation model is COCOMO model. When we are going to study about all these models also, Putnam's model or the statistical models, we are just going to see that, or we are just need to know that the best model among them model for making the estimation of any software project is a COCOMO model, and it is also one of the most used models. Right. Now we are going to understand about the 3 levels of the models. The first is my basic COCOMO model, second is my intermediate COCOMO model, and the third is my detailed COCOMO model. Just a second. Sometimes I need to check you all are there or not. So, discussing about this levels of the COCOMO model, what happens in the case of the basic COCOMO model? In this case, a single value model that computes the software development cost as a function of estimate of LOC only. Fine. In the case of the basic model, what is happening? The estimate of the cost is being made on the basis of the estimate of your LOC or the line of codes only, right? It just computes the software development cost on the basis of the line of the codes which are being present into your software. That is being considered into the case of the basic COCOMO model. So it is focusing on to what? It is focusing on to the line of the codes. Now in the case of the intermediate COCOMO model, this model computes the development cost and the efforts as a function of what? Program size and also the set of the cost drivers. So in the case of the intermediate COCOMO model, 2 factors are taken into the consideration: size of the program and also the various set of the cost drivers, means the cost of the various another things, and that is going to be computed in the case of the COCOMO model along with the LOCs. Now, in the case of the detailed COCOMO model, this model computes the development effort and the cost, which incorporates all the characteristics of the intermediate level with assessment of the cost implication on each step of the development, analysis, design, and testing. In the case of the detailed COCOMO model, there is an estimate of the cost is being made. And how this estimate is made? This estimation is made by considering the development steps of the software development model. Means if the software is into the analysis phase or software is into the is into the step of requirement analysis, here also the cost will be computed. Then if the software development is into the design phase, again the soft cost computation will be made over here. Then if the software is into the testing phase, again the assessment of the cost computation will be considered over here. So in the case of the detailed COCOMO model, it just go step by step, step by step, step by step. And in the case of the intermediate COCOMO model, it is just going to consider the LOC and also the set of the cost driver. Whereas in the case of the basic COCOMO model, the estimate of the LOC is just going to be performed. Now, there are three classes of the software projects in which it is divided, right? This model may be applied to the three classes of the software projects. What are all the three classes? Organic projects, semi-detached projects, or the embedded projects. So what are organic projects? Organic projects are the small size projects, a simple software projects where the development team has the good experience of the application. There is simple small size project that is going to be come to the organic project category. Now we have the semi-detached project category. In this, an intermediate size project, and the project is being based on to the rigid and the semi-rigid requirements. Third is my embedded project, the project developed under the hardware, software, and operational constraint. Examples are embedded software, flight control software, or the washing machine software, or microwave oven software. So in this case also the COCOMO model can be applied. So we have three categories of the model, or three categories of the classes of the software onto which the COCOMO model can be applied. What are these? These are the classes of the software. Okay, one software is falling into the class of the organic class. Second software is going to fall into the category of the semi-detached class, and third is the embedded class software. So these classes of the software are there. Then this COCOMO model can be used for estimating the software project development process in all the three classes, right? If the software is falling into the category of the organic, that means it is a small size project software, and yes, the COCOMO model can be applied onto this category. If the software is of the size of the intermediate in nature, then again it is very rigid and semi-rigid. It has got the rigid and the semi-rigid requirements. Then again the COCOMO model can be applied onto this kind of the software also. And if there is a embedded kind of the software, then also the COCOMO model can be applied onto this. Now we have got the equation which is called as E is equals to A S raised to the power B and M, where A and B are the constraints that are determined for each models. Now, E is what? E is just saying us efforts. S is the value of the source in LOC, and M is the multiplier that is determined from a set of 15 cost drivers attributes. So all these equations, you just need to remember the equation, and you just also need to remember about these things, what E is, what S is, what M is, and then they can be used if in the near future you are in any of the organization and then you are in requirement of the COCOMO model, then you must know about the equation, and you also must know about what these symbols in the equations are representing. Now we have the following are the few examples of the above cost driver. We have said over here that the M is the multiplier of the various cost drivers. Now what are these cost drivers? The cost drivers are these. It could be the size of the application database. It could be the complexity of the project. It could be the reliability requirements for the software. It could be the performance constraints in the runtime. It could be the capability of the software engineer, and it could be the schedule constraint, and so on. So these are all the things which could be considered, and there are a set of 15 cost drivers just like that, and where it is going to be used, it is just going to be used into this equation. So about the COCOMO model, you just need to understand about the kind of the classes of the software projects onto which the COCOMO model can be applied, which is going to be organic, and the semi-detached, and the embedded. And you just also need to know about the various levels of the COCOMO model, who has developed the COCOMO model, what is the equation of the COCOMO model, and also what is the full form of the COCOMO model, and plus what is the function of the COCOMO model. And this is, if you know the COCOMO model, that means you know the most important model of this software project estimation. Moving on further, we're just going to see another models also, which has not become very famous, but they are also they're also existing. One is a Putnam's model. So what this Putnam models is saying, L.H. Putnam developed a dynamic multivariate model of the software development process based on the assumption that distribution of the efforts over the life of the software development is described by the Rayleigh-Norton curve. So all these are basically the equation-based model, which could be I think, read or discussed by you people only. I think you can read all of them, or even if you will ask me, I'll just read them for you. What this Putnam model is saying, this Putnam model is saying that it is based on to just segregating the efforts over onto the overall development of the life cycle of any software. What it is doing, it is just distributing the effort, and it is just making use of this Rayleigh Norton curve, which is not being given into this document. That what this curve is saying, basically this curve is equal to the total life cycle efforts. It is just, in the case of the Rayleigh curve, the area under this curve is going to depict the total life cycle efforts. Now, in the above equation, we have got P is equals to KT exponential of T square divided by 2T square, and the bracket close, and then we have got the T square again. What this P is the number of persons working onto the project at any particular time T. T is everywhere representing the time, small t. Capital T is just the development time, overall development time. K is the area under the Rayleigh curve, which is equal to the total life cycle efforts. So that is happening. This is the equation of our Putnam's model. Then we have the another equation, which is going to help us in the estimation of the efforts at any time during the development of the project. This equation can also be used, and in this equation, S is representing as the number of the delivered lines of source code. C of K is representing in the state of the technology constraint, because every technology has got its constraint. K is the life cycle efforts in many years, and the T is representing as the development time, as it was representing onto our above equation in the Putnam's model. So moving on, there is another kind of the model, which is the statistical model. So sorry. These are all the equations in the statistical model. I think we will be moving ahead, and we are just going to see a number of automated tools are also available to us for the estimation of the project. Automated tools are, we are just going to see it from here. So this is the list of the automated tools. Name of the tool is given to us, estimator tool, who is the vendor, and what is the functionality of the tools. So this is the entire list. These are the number of the tools which are available to us in order to make the software project estimations. We can make use of all these tools also in order to make the estimation of our software project. Okay. Now, with this, I think we are coming on to the completion of this part. Have you able to understand this software project estimations and the various types of matrices? It's just that you, in the case of the automation tool is doing what? Automation tools is basically automating the process of software project estimation, right? And they have given us the entire list of the tools which are being available. You just need to know the name of the tools, and then these are all the vendors of the tools. Is there any problem in this case?
No, ma'am.
Okay. Now moving on to the another unit, which is going to be our unit number 6. It is going to discuss about the risk management and the project scheduling, right? Till now we have discussed about what? Till now we have discussed about the estimation, right? We have there are 4 factors about whom we are estimating. What are all the 4 factors? What we were estimating? We were estimating about the
Size,
we were estimating about the size. We were estimating about the schedule,
cost.
efforts, and the cost, right? Then now we have discussed about the estimation part. Now moving on to this unit, we are going to now estimate about the risk part, right? What are all the possible risks that could come into our software project development? Because we know that there is nothing which is saved from the risk. Risks are probability of happening anything. That are the risk. Anything could happen, right? Even if there is a very less amount of the chances there, but the chances there now, the risk is there. So we are just going to see what are all the risks that could happen, what is the meaning of the risk, how to identify those risks, and how to manage the risk. Before happening of any of the difficult situation, it is always advisable to manage the risk. It is always advisable to identify all the risks into your software and to manage them before anything not good happens, right? So we are just going to see what is risk or what is the definition of the risk. So a risk may be defined as a potential problem. Obviously, the risk is always defined as a potential problem, means a problem that could occur. There is a probability of happening. There is a situation in which this kind of the problem may arise. So that is called as a risk. Again, I'm going to just say it. It is defined as a any potential problem. So when we make use of the word risk, it is like it may or may not occur. There is no fixed thing. There is no certainty that it have to occur. No, but in the case of the as we are developing the software, it is very important for us to even consider the risks, whether they occur or they may not occur. If they occur, what will be the situation? So just prevent our system from those particular things comes under the software risk. So, but it should always be assumed that it may occur and necessary steps are to be taken. So from the perspective of the designer of the software, what should be taken into consideration? It should always be taken into consideration that if there is a chance, then the risk is going to be happen. Then only it is just going to be eradicated. Because when we take the situation like that, like this, that we have found that this is going to be a risk, then how we are going to think about that risk? We are going to think in the direction of happening of that particular thing. And when we are going into the direction of happening of that particular thing, then only we will be taking the necessary steps to stop that thing to happen. And risks are always considered into the negative directions. They are not advantageous, right? Sometimes means when we are taking the steps to remove them, we are just going to be consider them into the disadvantageous direction only. So risk can arise from various factors like the improper technical knowledge or the lack of the communication between the team members, lack of the knowledge about the software products. There is could be any market risk, hardware resources, competing software companies. So these are all the factors in which the risk can occur or in which the risk can arises. Right, these are all the situations. Now we are going to see about the basis for the different types of the software risk, why the risks are there, what are all the things which are causing, which are inviting the risk into our software. So these are all the points that are describing that if any of these points are existing, then there is a possibility of the risk to the software. First is our skills or the knowledge, means the person who are involved in the development of the software, if they do not have the proper skill, if their knowledge is partial, if they lacks in the adequate skill, then there can be a situation where the product may face the risk. It could be at the current stage of the development or it could be at the later stage, because we have seen that there are a number of people who are involved into the overall development of the software. The people are involved in the requirement analysis phase, the people are involved into the designing phase, coding phase, and then testing phase, and then the maintenance phase, and there are many more phases which are there, right? If the people concerning with any of the steps do not have the proper knowledge or do not have the as much amount of knowledge which is being required to perform that particular skill, then there is always a risk. So risk can occur in any of the stage in the development of the software. It could be into the initial stage or it could happen into the later stage also. It depends on to the skill or the knowledge of the people who are involved in its development. Now, second kind of the basis for the software risk is your interface modules. Means the complete software contain various modules and each module sends and receives the information to another module, and the concerned data types have to match. Interface modules means, as we all know, that we always develop the software in the form of the modules only. Now, when the various modules are playing their own roles, then and they are being developed by the different set of the peoples, then different set of the teams of the people, then there shouldn't be any chances that the data types are not matching among the modules. If the data types are not matching, then they will not be able to communicate properly. Then there will be a certain kind of the defects that will be existing. So that comes under your interface modules. Then poor knowledge of the tools. Whatever the tool will be used by the company for the development of its software. For example, in the earlier unit only, we have talked about the software estimation tools. So if the person do not have the proper knowledge of how to make use of these tools or how to just operate these tools, then in that case also there could be a condition when the various kinds of the risk can arise. Next important situation is your programming skill. Now, the code developed has to be efficient, thereby occupying the less memory space and the less CPU cycles to compute given tasks. Now, it may happen that the programmer of the company do have the skill to program the software. But what is required? It is always required that such kind of the program is developed where the less memory space of the system is being used and less number of the CPU cycles are utilized in order to compute the particular tasks. So if such kind of the program uh, is being made by the programmer, then it is fine. Otherwise, if the programmer is just creating a program, just coded the software, the code is being working efficiently, but the thing which is happening is that his thing which is happening is that the program is requiring a more amount of the memory space. The number of cycles required for the computation purpose is also again more. Then that kind of the program cannot be considered as the more efficient program. That kind of the program will be considered as the correct program, but it will not be considered as the efficient program. Now, the next kind of the risk that could occur because of the situation in the management issues. Obviously, a number of the persons are involved in the development of the project, right? So there is an entire department which is responsible for the management of the project staff. Like the management should always be focused towards arranging the recreational activities for the project staff, for bonuses, for promotion. Means if the project staff is happy, then only there should be an expectation of developing a good software, right? If there are any managerial issues which are existing into the organization, obviously they are going to affect the development of the project also, because that are ultimately going to lead to the bad coordination among the people involved. So, and that is going to affect the overall development or the overall schedule or overall quality of the software projects. Next thing is update into the hardware resources. The team should be aware of the latest updates that have happened into the hardware resources, such as the latest CPU that has come into play, various peripherals. So those updates should also be available to the peoples. Now, if the extra support if is being required, the software should be able to support a set of the few extra features in the vicinity of the products to be developed. A number of the extra features should also be developed so that the software performs a number of extra functions also. Customer risk is there. Customer also should have the proper knowledge of the product which is being needed by him and should not be in a hurry to get the work done. Because if the customer is going to be like in a very hurry kind of the situation, then it is again going to affect the entire software quality. Now he should take care that all the features are implemented and tested. He should be knowledgeable enough that whatever the requirements has been placed by him, all those requirements are being fulfilled by the software product that is being delivered to him. The software have all the features which have been asked, and all those features are also being tested properly. So customer should give the enough amount of time to the developing organization also. Next is there could be the external risk that could happen. For example, there could be any calamities, like the natural calamities could occur, like the flood situation, earthquake situation. In that case, all the backup should be taken into the CDs or the tape drives or whatever be the hardware stuff which can be used for taking the backup, and every backup should be taken into the encrypted form only, so that no infringement of that backup could be made by any unauthorized person. Next are the commercial risks. What are the commercial risks? The organization should be aware of the various competing vendors in the market and various risks involved if their product is not delivered on time. Commercial risks are, that for a particular, there are bids that are being performed, and there are various competitors of any particular organizations which are sitting into the market, and if you're not developing a good quality software product, and plus along with the quality you are not just providing this product on time, then that could hamper your image into the markets. And you know that there are various other organizations, various other companies which are sitting to take your project, and you just do not want your image to be affected by any such kind of the thing. So these are all the kinds of the commercial risks. So these are all the factors which are telling us about the kind of the different types of the software risk. Skill or the knowledge could be a basis. Now the interface modules, poor knowledge of the tools, programming skills, management issues, updates in the hardware resources, then the extra support is there, then the customer risks are there, and the external risk, and finally the commercial risk. Then we are going to read about the another point or the another note over here, which is going to explain us about the monitoring of the risk, how to monitor all these risks that could happen, because we are just studying about the management of the risk. Risk would be managed then when they will be monitored. First of all, there is a need of monitoring the risk. Now we are just going to read these lines which are saying that various risks are identified under risk monitored table with attribute right like risk name and the module name and the team members involved, lines of code, codes affecting this risk, hardware resources, etc. is maintained. So this kind of the table is being maintained by the risk management team. What kind of the columns the risk management table can have? It can have the column names as the name of the risk, name of the module in which that risk can come, what are all the team members which are involved in the development of that particular modules, how many lines of codes are going to be there, what are the codes affecting this risk, which part of the code is affecting, or by which part of the code the risk can happen, then the hardware resources which are being utilized in the that particular module, and etc. This kind of the table is being maintained in order to monitor the various risks. So if the project is continued further to 2 to 3 weeks, and then further the risk table is also updated, right? You just see the risk, right? Then after that, risks are trying to be eradicated, and according to the situation, the risk table kept on updating. Now, this is how a risk table 6.1 risk table monitor is being depicted by this table. It depicts the risks that are being monitored. For example, the name of the risk is module compute, right? Week is week 1, line number in which line the risk can arise in the code, line number 5, line number 8, line number 20. Then when the week 2 come, it has been seen that the risk has come on to the line 5 and line 25, and there is a priority that is being given to this risk. Priority means it is the how much strong the risk is, and according to the strongness of the risk means how much is the probability of happening of that particular situation, and according to that probability these priorities are being set, and according to these priorities these risks are managed and maintained. So we can read it from here also. The above risk table monitor has a risk in module compute where there is a risk in line 5, 8 and 20 in week 1. Week 1, line 5, 8 and 20 has got a risk in the module compute. In week 2, risks are present in line 5 and line 25. Risks are reduced into week 2 because we have seen in week 1 there were 3 lines onto which the risks were there, whereas in the week 2 the lines has got reduced. So the priority 3 is set. Similarly, in the second row, the risk is due to more memory in the peripherals affecting the module F1, F5. Then in the week 1 and module F2 into the week 2. So the priority 1 is being set for this particular kind of the risk that can happen. Right. So this is how we are going to read this table, and this is how we are going to understand about this table. So in order to monitor the risk, we just take the help of the tables. We just create the tables which are going to include a number of the columns, including the risk name, module name, team members involved, line of codes affecting this risk, hardware resources, etc. And then these tables are kept on updating according to the risks, according to the quantity of the risks. If the risks are less, then the table is updated. If more, then again it is updated. Now we are going to see how the management of the risk is being performed, or what is the risk management. A priority is given to the risk, and the highest priority risk is handled first. As we have seen that it has got the priority 3, it has got the priority 1. So the highest priority risk is going to be handled first, because with the highest priority, there are more chances of happening. Various factors of the risks are: who are the involved team members, what hardware and software items are needed, where, when, and why are resolved during the risk management. Now, the risk management, entire task of the risk management is categorized into these steps. First is the risk avoidance, second is the risk detection, third is the risk control, and the fourth is the risk recovery. What is coming under the risk avoidance? The risk anticipation and risk tools. What is coming under the risk detection? There are 3 important points that are coming into it. These are risk analysis, risk category, and the risk prioritization. What is coming under the point number 3? It is risk control. 3 points coming under this is risk pending, risk resolution, and risk not solvable. What is coming under point number 4? It is risk recovery. And what kind of the recovery can be performed? Either it could be a full recovery, either it could be a partial recovery, or either it could be a extra or the alternate features of the recovery. So this is how this entire process is being shown to you in the form of a picture. Start the risk manager, risk avoidance. We are just going to read it and then we are going to see it. What is happening into the case of. So from the figure 6.1, it is clear that the first phase is to avoid the risk. Obviously, we do not want any situation to come to us. That is why the most important thing is to do what? To avoid the risk by anticipating and using the tools from the previous project history. Obviously, we always make use of the previous project history in order to anticipate the kind of the risk that could happen. In case there is no risk, the risk manager halts. Look at this. We have started the risk manager. We try to avoid the risk. In case of the no risk situation, the risk manager is going to be halted, right? We have tried to avoid the risk. There is no risk found. And then in that situation, the risks are ended. Risk avoidance is being performed. How? They are being performed with the help of anticipating the risk and by making use of the risk tools. Now, if the risk avoidance is not true, is not happening, then what is happening? It is going to go to the risk detection part. Risk detection is performed with the help of the risk analysis tools, risk category, and by performing the risk prioritization. These are all the 3 important points which help us in the detection of the risk. After that, it is going to go after the detection of the risks. They are going to be sent to the another part, which is going to be the risk control part. Risk control is going to control those risks with the help of risk pending. It is going to tell us what are all the risks pending, what are all the risks resolved, and what are all the risks that are not solvable, right? If there are another risk which have been found by this risk control, it is again going to send that to the risk detection that detect this situation, whether it is a risk or not, right? Then after the risk control, the risk recovery is being performed, whether the recovery is being performed fully, partially, or there is another extra or alternate thing that is being done. And then the risk manager is being performed. So we are going to read it from here. In the case there is a risk, detection is done using the various risk analysis techniques and further prioritizing the risk. And in the next phase, the risk is controlled by pending the risk, resolving the risk, and in the worst case, if the risk is not solved, lowering the priority. Lastly, the risk is recovered fully, partially, or an alternate solution is being found about that particular situations in which the risk has arisen. So this is how this diagram or the entire figure is explaining to us the overall process of the risk manager tool, how the risk manager tool function. The risk manager tools function like this. Start the risk manager, then try to avoid the risk. If there is no risk found, end the risk manager. How to avoid the risk? By making use of anticipating the risk and by making use of various tools. Now, risk has been anticipated. Risks are going to be detected in this second part or in the second phase by making use of analyzing the risk, categorizing them, and then prioritizing them. Then the detected risks are sent to the risk control and they are being trying to be resolved. They are being put into the category of the pending or the not solvable. Then the risks are sent into the recovery step, and into this step it has been seen that whether they have been recovered fully, partially, or there is another alternative if they are not recovered at all, and then we are going to end this risk manager. So this is a process which help us into the overall management of the risk. Now we are going to read about the avoidance, all these phases. Again, also what they are saying to us, the risk avoidance is being performed by making use of the risk anticipation and the risk tool. Anticipation is done by seeing the previous projects or the past projects or the historical project, and on the basis of that experience it has been anticipated that whether the risk can occur or risk cannot occur, and it is being done by the project manager only. Then in the case of the risk tool, they are used to test whether the software is risk free or not. The tools, as we have discussed above also, as there are estimation tools existing, similarly there are the risk tools which are also existing. So the tools have built-in database of the available risk areas and can be updated depending upon the type of your project. Now, how the risk detection is being performed? The risk detection algorithm detects a risk and it can be categorically stated as risk analysis. So this table is showing us how the risk analysis is being performed. In this phase, the risk is analyzed with the various hardware and software parameters as the probabilistic occurrence, weight factor, hardware resources. Weight factor is going to include what? Hardware resources, lines of codes, persons, and risk exposure is going to be a multiplication of the probability of the occurrence and the hardware factor. So the maximum value of the risk exposure indicates that the problem has to be solved as soon as possible. As we can see that 140 is the maximum value. So this problem needs to be solved as soon as possible because it is on to a high risk. A risk analysis table is maintained as shown as above. This is how we maintain the risk analysis table. It includes the name of the risk, the probability of occurrence of that particular risk, the weight factors that are being involved, and which includes the hardware resources, line of codes, and the number of persons involved, and then the risk exposure is being calculated by multiplying the probability of occurrence and the weight factor together. And then we analyze this table, and the risk which has got the highest risk exposure is going to be tackled first, is given the highest priority. Now the second thing which is going to come in under the risk detection is the risk category. Now risk identification can be from various factors like the persons involved in the team, management issues, customer specification and feedback environment, commercial, technology, etc. Once proper category is identified, priority is given depending upon to the urgency of the project. Now obviously what is going to happen into the risk category? There is going to be a classification of the risk according to the persons involved according to all these important factors that are being written over here. It could be the persons involved into the team. It could be onto the basis of the management issues or the customer specifications and the feedback, or the environment and the commercial or the technology basis. So these are all the factors that could be used in order to categorize the risk, that they are falling into which category. Now the risk prioritization, depending upon the entries of the risk analysis table, the maximum risk exposure is given the high priority and it has to be solved first. Now, the next step is your risk control. How the risk is being controlled? It is risk pending stage, then the risk resolution, risk elimination, risk transfer, risk disclosure, and risk not solvable. So risk pending includes what? According to the priority, the low priority risks are pushed at the end of the queue. Means these are the risks that could be handled later on. So risk pending is basically to move your risk into the priority queue according to their exposure. If they are of high exposure, they will be high into the priority queue, and if they are of low exposure, they will be like low into the priority queue. Second is your risk resolution. Risk manager makes a strong resolve how to solve the risk. Risk resolution means the situation which is going to explain us how to solve that particular risk. Elimination means try to just leads to the serious error into the software. We just try to eliminate the risk. Risk transfer, if the risk is transferred to some part of the module, then the risk analysis table entries gets modified. From one part to the another part, we just try to transfer the risk so that it does not affect this particular pass. Disclosure, it is announce the risk of less priority to the customer or display the message box as a warning. Sometimes what we have, whenever we are making use of any particular website, there is a particular warning that is being displayed. So it is like you just inform the customer about the happening of the risk, or you can also inform him by displaying the message box as a warning that if you're going to do this, this is the risk which is being involved in this functioning of your. Then next kind is your risk not solvable. Risk not solvable means the category of those risks which cannot be handled by the organization, and thereby it is notified to the customer, and the team members propose an alternate solution to that. If there is particular kind of the risk that has occurred and it has been found by the team members that this risk cannot be solved, so in that situation the first responsibility of the team is to inform the customer about this situation, that there is this kind of the risk which has occurred and this is a non-solvable, and this is again, and the another responsibility of the team is to just propose an alternate solution to that particular kind of the situation to the customer, and then discuss him and go further whether he is agreeing with that particular situation or not. Now, next in the diagram, what we have the risk recovery. So we are going to study about the risk recovery also. There are three kinds of the risk recovery. There are three situations in this, whether it is going to be full recovery, it is going to be partial recovery, or it is going to be extra or the alternate features. What is happening in the case of the full recovery? The risk analysis table is scanned, and if the risk is fully solved, then the corresponding entry is deleted from the table. Means you have recovered the risk, you have fully solved the risk, then the table from the analysis table, then the table from the risk analysis entry from that particular table is being deleted. Partial means not the entire portion of the risk is being solved, but some portion of the risk is being solved. So that entry is also being updated into the table. Extra or the alternate features, sometimes it is difficult to remove some of the risks, and in that situation we can add a few extra features which solve the particular problem. Therefore a bit of the coding is done to get away from the risk. This is later documented or notified to the customer. So this is happening into the case of the extra or the alternate feature. You just inform your customer that this is the particular situation and these are all the alternative solution to this particular situation. These are all the extra or the alternate features that could be added to your particular software. If you agree with that, we are going to go ahead. If you do not agree, we will just propose you another kind of the situation. So these are all the three important terms which are coming into the risk recovery. It is full, partial, and extra alternate features. Next is our formulating a task set for the project. I think we are going to discuss it in our next class. Fine.
Yes, ma'am.
Okay, ma'am.
Okay. You all must be having, just a second. Let me just stop this presenting and recording. So what